Everybody's rolling in from the prior session, so we'll just give it a few minutes here. It's great to see there's about 250 people online through this, so it's great. All the engagement and Slack. So what time is it where we're at, Tarun?
It is 10:45, like 10:48, yeah, p.m.
Great.
Yeah.
Thanks for being here for the community for sure. So I'm going to play some quick videos here and then intro and we'll get rolling. All right. We got one more, my favorite one coming up.
With Nagarro's diverse range of resilience engineering services, you can build robust and reliable systems and ensure business continuity. Our tailored solutions ensure that your brand has the unbeatable advantage of staying at the top, even during unforeseen events.
All right, great. Well, hi, everybody. My name is Matt Schillerstrom, and if you were on the keynote, you saw my introduction already, but I'm so thankful and glad to have you all here watching. And I'm so appreciative of Tarun from Nagarro presenting today. Had I listened to his talk when I first started my chaos engineering journey, like in 2016, I think it would have changed my life. At least I would have less gray hair, and I would have changed. I would have evolved my program at Target rather than taking it 4 years. I would have maybe done it in less than time to that. Again, Nagarro's giving some workshops later in this conference, and they have a booth, so please swing by and stop and talk to them. They're also very active in the Slack channel, so if you have any questions, feel free to go there as well. But yeah, I'll turn it over to Tarun here. Welcome, and I'll let you share your screen.
Sure. Thank you so much, Matthew. Hope everyone is doing good. So I'll start with a quick introduction about myself. I have been in the software industry for around 9 years now. Been with Nagarro for 2 years. I've worked as a developer, as a Devops engineer, and currently working as a resilience engineer for past 2 years almost for different Nagarro clients. I've been working with as many customers for the initiatives of chaos engineering, especially. We are enabling, as Nagarro, we are enabling them to instill confidence into their systems, into their teams, and also use, of course, by using chaos. And since I have understood resiliency, so I feel that I'm more comfortable with the chaos in my life as well. And yeah, that's about me. Okay, welcome again. So this talk is about shifting left with chaos testing to deliver resilience and reliability at scale. How do you enable large enterprises to run resiliency and chaos engineering tests at scale? Let us look into a unique approach of democratizing the chaos engineering fault injection experiments into your own delivery pipelines. This talk is about a journey that started almost a year back. And yes, our partner in this journey is a Fortune 500. We have a decade-long partnership with this customer. What we have seen is that there are some things like SLO breaches, zone outages that are taking longer to recover. So though we work in different areas, this is what led us to go to our customer and say, okay, let's try chaos and see how it works for you. So we started this journey with the goal of establishing and making a reliable system. We started this journey a year back, and it's been almost a year, which I'll tell you where we now stand at. But yeah, it's been interesting so far. To achieve our goal, we architected a shift left chaos framework. Now there are two questions: why, shift left, and why chaos? So let's see why chaos first. With SLO breaches and zone outages taking almost days to recover, we thought that chaos would be a good fit in this case. Though the end user was a bit frustrated with the product at certain times. So, yes, that also was a good motivation for chaos. Why shift left now? So, the traditional approach that chaos engineering came up with when Netflix or other organizations started is to run these fault injections into production systems. But what happens if you're not confident enough to run these injection faults into your production systems? You might not have a mature system, you might not have automatic recovery, but that should not stop you from running chaos. And that is what we started with. Now let's see how we did it. We first started by analyzing the existing application and the gaps that we could identify which were causing different type of failures. So the landscape was very huge. There are almost 2000 plus customers logging into the system at any given time, doing variety of stuff. There are multiple integrations that are done to external systems. The applications ranged from variety to Java, Python, messaging systems like RabbitMQ, Kafka, caching systems like Redis, databases with terabytes of data, and that to both Postgres SQL and NoSQL databases like MongoDB. There were parallel streams of multiple developers working to deliver quarterly releases, which led to faster development. But yeah, the product was getting lesser and lesser reliable because there were features that were added, but yeah, the confidence was not increasing. We identified certain potential key issues in our initial analysis. First, it was misconfigured timeouts. So applications tend to have timeouts that are configured, and if you have them misconfigured, and by that I mean if you have something that is either too long timed out or too short, in both cases, it is not helpful. If you have a too long timeout, then the end user might leave the screen. The end user might get frustrated because they would not get to know what is happening during the time when you have a long timeout. And one such example with us was in certain cases, the login screen was taking up to 5 minutes because the backend systems were actually switching over or failing over. Next is inadequate fallback strategy. So systems are developed with certain fallback strategies in place, but how to test those fallback strategies? So having a strategy and not testing it is similar to not having one. So we thought, okay, let's give them something that could actually test these fallback strategies. Again, the example here was a load balancer that had a primary secondary configuration. The switchover from secondary to primary was around 5 minutes. But for those 5 minutes, the customer does not know what is happening behind the scenes. Next is unpreparedness to zone outages. So the landscape was majorly on cloud. When we think of cloud, the availability zones come into picture, and just installing your systems into different availability zones does not guarantee that it would work. Supposedly, you have a database which is running one master and maybe three replicas alongside, and they are all in different availability zone. What happens if the master goes down? What happens? How do you test that the switchover is uh, smooth enough so that you can actually the customer is not it is so seamless that the customer or the end user is not impacted at all of this led us to the part where we thought, okay, let's now begin our journey and try to implement. The primary motivation for shifting left was, of course, our non-confidence in our production systems. So that is why we thought that, okay, let's not do production, but instead do something that can be done at developer level. We identified certain process gaps and challenges while we implemented shift left too. So it is not that we just came up with an idea and it was like, okay, let's do shift left today. No, there were different things that led us to shift left. There was a journey which we still have ongoing we run experiments that are not shifted left. First, there was lack of processes or frameworks to replicate events. Now, there would be multiple production incidents happening in your system. They could be due to misconfigurations. They could be simply due to a bad build passed through. But yeah, there would be use cases that would be easy to replicate. But we do postmortems, we do incident analysis. But how do you know the root cause that is identified is the correct root cause? In order to do that, you can actually replicate these, but how? So we thought of something that, okay, if we are able to bring to the left a developer, a system or a mechanism which could actually help a developer to replicate some production incidents, it would be good. Another challenge was the absence of mechanism to control the experiment. So supposedly we even started with fault injection and chaos engineering. There was no way to conduct those. There are so many tools in market. There is no way that we would be doing an evaluation of such a big landscape, identifying, because this is a landscape that is both on Kubernetes, on VMs, on prem. So, and also training new individuals for chaos engineering was another challenge. And lastly, and for me, this is very close to the heart. So there were matrices that were available. So for people who are new to this concept, SLI is something called service level indicator, and SLO is something that is a service level objective. We do set up SLIs and SLOs for system, but are they derived from the SLAs that we have promised the end user, or are they just existing in the system? Are you even measuring the correct SLIs for your system? What we found that there were certain matrices, but yeah, not necessarily they were the correct ones or they were the useful ones. They were not benchmarked for this for us to actually see whether what is impact or how much is the impact. So we started a journey from pre-production to staging to integration environments and then to service level experiments that could be executed in your pipelines. Let's now understand how and where in the build pipeline this was introduced. So a traditional pipeline starts with a developer pushing code to a version control system. The version control system could be any ranging from GitHub, Bitbucket, etc. Once your code is in code repository, it would poll for changes. The CI tool would actually poll for changes. The tool could be Jenkins, GitLab, or whatever your organization is using. And then there are stages that you run. There could be static code analysis. You would be running tools like SonarQube. You would be running certain unit tests. You might be running other type of tests too. Essentially, after completing all of this, if everything succeeds, you build a package, you create that package and push it to a repository. Once in a repository, the deployment manager, you can also use Jenkins, but yeah, we use deployment manager to actually deploy this to different environments. You can begin from lower environments and then it gets promoted to the higher environments. But wait, did I miss where is the resilience engineering part? Okay, let's see. First, after deploying your clusters, I think the essential thing that we wanted was the setup of the monitoring and observability tools, so that we could fetch information that is important. We could fetch SLIs that were meant for those services. And that is where observability and monitoring observability comes into picture. So you could start with smaller golden signals like error rate, latency to begin with, and then you could go to more advanced ones. Then we introduced a stage after all of this was deployed, which was called resilience experiments. So these resilience experiments would run, and this is a list of resilience experiments. So how now the question arrived, how would a developer decide what should run? And I think you need not to be an expert to run chaos. So since you are a developer, you have built it in a manner that you know that, okay, it is resilient to certain faults. We are just enabling you. So we enable them to run fault conditions. We worked with different development teams to identify a lot of use cases. Eventually, we ended up having a repository of a lot of experiments in place. These experiments range from simple experiments like CPU, memory, disk hog. There were network experiments leading to complete network outages. then introducing latency into the system, and experiments such as VM shutdown, just shutting down your VM and seeing whether the system is good enough to continue working. All these experiments were configured in a repository, and depending upon the use case or the type of application, you could actually design and pull that, okay, these are the experiments I want to run. Once these, what essentially happens behind the scene is we use different API calls, we use different tools, we use custom chaos, which is now which does not let you know, okay, so you do not, as a developer, there is no need to understand what is running behind the scenes, so you do not have to learn a new tool at all. This package would then inject chaos, which would then actually show some matrices on your observability system. Another challenge is now the developer has to go to the observability system, but no, that part is also taken care of. We took SLIs and SLOs as input and we validated it. You can validate your SLIs against your previous build. You can validate against whatever you have set as a benchmark for your system. If the test passes against any of those, you feel the test is passed. Else, the test can be concluded that it needs improvement and you need to work on the system to make it pass. So this is essentially introducing a single stage without the developer knowing what is happening behind the scenes. We conducted a lot of successful experiments. We are still doing this. We are onboarding new teams. There are new applications that are being developed. We do this in continuous manner. What essentially is happening is the overall confidence is now built from smaller blocks. Those smaller blocks are leading to an overall confidence into the system, and we hope that we would reach a stage where we would be able to run these in production someday. But yes, for now, we are instilling confidence into developers. We are instilling confidence into stakeholders that yes, our system would work and is ready to and is ready to face outages or prevent them. What were the key actions that were performed? So the lack of process and framework was actually now you have connectors, plugins, and you have other things that you could actually run from your development environment, and you could replicate events that are there in production. You could analyze the production issues, design experiments on your own. Also, take help from the team, which is us as a centralized team. We also work to help understand developers with any use cases that are coming up. Then the absence of mechanism was actually taken care of by the pipeline now. So you don't have to worry. You don't have to learn any new tool as a developer. The whole setup is democratized. You know that, okay, I just have to run this experiment and see whether my system is resilient enough. The SLI SLOs have been set up. So we started basic, as I said, network latency or response time, error rate. You can also calculate mean time to recover, mean time to detect. And then lastly, there was something that we introduced as a concept to generate some certain amount of value, and that was the resiliency score part of it. We calculated a resiliency score that was based on certain factors. So if your experiment is resilient to certain experiments, then we told that, okay, this is a score that you get. And overall, your service is either red, green, or yellow. So if you are red, it means you're non-resilient to majority of the failures that we are hoping might happen, which might happen. We're not hoping them, sorry, which we are thinking that might happen in production. But if you're green, then you're resilient enough to actually either withstand them, mitigate them, prevent them. Yes, that is what we came up with. This resilience score essentially is a average of different type of experiments that we did, and also you could, with the help of this score, you could see how resilient with every incremental code releases or every build you are becoming um, with every release. And lastly, how were we able to do this? So there were many mountain peaks that we climbed. We currently we started with small nodes that could actually run just API tests or maybe certain smaller amount of tests. We now can run a larger performance test. We have worked well with performance teams to run performance experiments at the same time. We moved to the another peak when we started testing. We increased the complexity of attack types. So attack types increased, and they are increasing every time we are getting a new application. There are new use cases that come up. Uh, there are application level faults that we wanted to inject. The infra, as I said, is both VM, Kubernetes. We also partnered along with the cloud vendors to actually do some serverless experiments as well. So that is another mountain peak. Monitoring and observability, we are enabling developers not to actually set correct matrices, but also that they don't have to visit, that they do not have to do specifically metric calculation. All of that is automated. You don't have to worry, sit at your desk, run the pipeline, and just see what is happening. And all of this happened without any access operation. So there is no operations that was involved. There is no add-on that you have to do. So yes, currently we are running these pipelines along with a lot of developers. We are also running certain game days for complex use cases. That's it from my side. Thank you. And if you have any questions.
All right. There we go. Okay. Sorry about that. It always takes a couple seconds to load that up again. Great presentation. Loved it. We got 2 questions for you and we got some time. So first question I'm going to show on stage because that's a cool feature. So how are you able to generate and show the shift left value for the client?
So one was, of course, when you rate your services, you generate value in terms of number of experiments your application is resilient to. In terms of that we give that confidence, we give up. So it's not only confidence that we are just saying. So we are giving you facts that okay, this application is resilient. In terms of that, number of experiments that we are running is another value add that people are doing again and again. So I think. For shift left to add value, also we are changing the approach in terms of we are not asking the developers to actually learn any new tools. So we are just telling them, okay, you do what you do and we'll take care of the rest. And once it's done, I think we don't have to worry a lot about that.
Cool. I'll mark that as answered. If you have any follow-up questions, feel free to ask. All right, let's do. I like this question. Just shift right testing. You know, like we are talking more about shift left at this conference, but yeah, ideally, what does that shift right look like?
So I think it depends on the use cases. Certain customers are confident enough. Certain teams want to run them in pre-prod first, and then they directly go to prod. So it is completely dependent on what kind of application landscape you have, how much reliability I've already instilled. If you are confident enough that okay, yes, I can recover my system well, I do not have an end user impact. You can also run it in use cases wherein applications are not running 24/7. So run it in use cases at odd hours, maybe like maintenance windows happen off, maybe run it on Sundays, weekends when nobody is working. You would know that, okay, there is no impact. So shift right in those cases. I think these are there are certain use cases where shift right fits more better than shift left. And see, the overall intent in both the cases is to help develop that sense of reliability. Okay, the system will be able to sustain any outages that might happen. So you can opt for either of them, but yeah, it depends on the use case.
Perfect. Cool. All right, let's go with this. Were you able to forklift the solution to production? I like that word. If yes, how? If not, why?
Okay, so we are currently in a stage wherein we have not enabled all the applications. So I would say yes, no, we are not able to do it yet because I think it will still take some time to have that confidence in the overall system. So as I said, right, so this is some part of the journey that I wanted to share. We also do complex use cases via running game days, which also helps to see that the overall system is behaving fine in cases of zone outages. In other cases that are not actually could be done by developers. So with larger blast radius, we are running experiments. But we do see a potential wherein we see that, okay, we started a journey wherein people were reluctant to even run these experiments because they were not sure who would recover the systems. And at least now we are in a place, or I would say we are halfway through or more than halfway through, wherein we could now be, maybe next chaos conference, I would be here presenting that, okay, we are now running it production. So yeah.
All right. Well, looking forward to that conversation for sure.
Yeah.
We won't have to wait a year though. We'll have a meetup or something and you can talk about it.
Sure.
All right, cool. And then you are answering questions great. So let's go to the next one. Let's see. How about some key tests? Like if you I guess what they're trying to ask, like what are like one or two tests that you would start out with?
So when we give these to developers, I think the first one we ask them to do a normal shutdown. If you're on a virtual machine, there are CPU cases that are easy to do. That are so I have a very good use case which we ran recently, and we gave this developers. So usually, what people do with cloud native applications, especially this is an application that was running in Kubernetes. So what you do is you think that, okay, the pods will auto scale. I have set up HPA and everything. I am all set. But I think that is a bit, people don't understand this, but yeah, you have to also see how you want to scale, when you want to scale up. So you can't just set up your HPA with defaults and be like, okay, I'm happy now, I would scale whenever I want. So take that into consideration. But in order to answer and keep to the context, I would say run CPU experiments or VM shutdown experiments at initial stages. They are easy to understand. It is easy to identify what can be done for these type of experiments. If you are running network experiments, that you might need to, maybe at some point you might have to find that in the logs, or maybe you will have to configure further a few other things. So go ahead and run the test cases in, I would say, CPU and VM shutdown.
All right. So we are just at time. I'm going to take the rest of the questions and post them in our Harness community Slack channel for Chaos Carnival, because then other people can thread the answers too. Besides you answering, I'm sure there's other people that can engage in answers too. Then we can have some conversations there. But thank you so much. Appreciate all that you've done today for us and the sponsorship again. There's a workshop again tomorrow that you can join. I'm looking forward to that. And there's another keynote that Uma Makaro is speaking in about 15 minutes. So yeah, again, thank you for all the questions and the opportunity today. All right.
Thank
Bye,
you.
everybody.